Let's look at problem 1143, longest common subsequence. So here we are going to provide a dynamic programming solution. The reason we provide a solution to this problem is because we have promised to provide one when we look at Leetcode problem 583. These two problems are quite related, sort of similar. So here I will first analyze the problem and then give the dynamic programming recursion relation, and then I will translate the analysis into code. The problem statement is as follows. So given two strings, text1 and text2, so we are required to return the length of their longest common subsequence. So if there's no common subsequence, we return 0, such as in example 3 here. So here we need to distinguish subsequence from substring. The substring is a continuous piece, while for a subsequence, it's not necessarily continuous, but just as long as they keep the index order relation, that's a valid subsequence for a string. So here in example 1, so ACE is the longest common subsequence, which has length 3. In example 2, ABC itself is the longest common subsequence, which again has length 3, right? So the constraints about this problem is that so both the two texts are not empty and their length is bounded by 1000 above. So the text1 and text2 consists of only lowercase English characters. So now let's look at analyze one example. So here the method we're going to use is the dynamic program method. So method dynamic programming. So here I'm going to use a two-dimensional array. Some people write DP, or here I will use F. Basically, I will regard it as a recursion function. So here I will introduce this one, ij. So this is defined as the length of longest common subsequence of text 1 up to index I. In other words, up to the ith character, and text 2 up to the jth character, right? So when we want to determine this Fij, so we should have already know the information about this index, I-1, J-1, and I-1, J, and I, J-1, and this one is what we want to update. So the update relation actually is sort of trivial. So if we look at the definition of Fij, so we compare text1 character, the ith character, so with, in other words, character with index -1, and this one, text2 index J-1. So if these two are equal, so basically Fij is Fi-1 J-1 plus 1. So this equation can be interpreted like this. So the length, the longest common subsequent length ending at the index at ith character and jth character respectively is the length of the longest common subsequence ending at I-1 and J-1 characters plus 1. So 1 plus 1 is due to the common character, that is text1 I-1 or text2 J-1. So otherwise, so what not equal, if they are not equal, so we will have Fij, which we have two ways to get longest common subsequence. Either one is from word 1, text 1 up to n-1 and word 2 up to index g, or word 1 up to index I and text 2 up to index g. So because the current two characters are not the same, so the maximum of these two will be the longest common subsequence length. So let's look at one example to get a clear idea about this recursion relation. So due to the second constraint here, I will introduce some dummy characters so that I can easily set the DP table in the code. So for example, look at text 1. So I will use something like this: star A, B, C, D, and E. So this is the first character. And for the second character, maybe just choose one that is not in the vocabulary of text 1 and text 2. Then we will have A, C, E. So then, by the definition, so this whole, if you run from left to right, there's nothing common with this this symbol. So all this first row will be 0. Similarly, the first column is also 0. Because nothing is the same as the star. So we will have this. So now we just use this recursion relation. So here we look at A and A, they're the same. So we use the diagonal 1 plus 1, that is 1. And here we look at A and B, they are different. So we look at the left and above and choose the large one, that is 1. So here again, similarly, they are not the same. We choose the left and upper and find the larger one, that is 1 again. So similarly here, 1, 1. Now let's look at this row. So we have A and C, they are different. We look at this position and we look at this position. We choose the larger one, that is 1. So similarly, C and B, they are not the same. So we look at the left, we look at the up, so we choose the larger one, that is 1. So now C and C are the same, so we look at the diagonal direction and then use that number plus 1, that is 2. So D and C are different, but the nearby one at the left and above have value 2 and 1, so the larger one is 2, so we have 2 here. So similarly, C and E are not the same, but we need to choose 2 here, so that is 2. So let's look at the last row. We have A and E, they are different. So we can look at 0 here and 1 here, so the value here is 1. B and E are different. So we look at the left, we look at the above, and the value should be 1. C and E are different. We look at the left, we look at the above, and the larger is 2. So D and E here are different. So we look at the left or look at the up. So both values are 2. So we have 2 here. So lastly, E and E, they are the same. So we look at diagonal direction. So they have 2. So 2 plus 1 is 3. So finally, 3 is the longest common subsequence length. So with this example finished, let's look at the code. So basically, this will be very routine. First, let me make some preparation. Step 1, so make the DP table. So make the DP table. So first, for this purpose, I will track the length of the two texts. So text 1 and length, text 2, just for convenience. And here the DP table will be a two-dimensional one. So here I will multiply this by m plus 1 for dummy index in range m plus 1, right? So we automatically set this row and this column to be 0. So now we iterate or update using recursion relation. So this is the routine for a two for loop for I in range. So now it's from 1 to m plus 1. And then for j in range, so 1 up to m plus 1. So now the thing is that we need to compare if these two are the same or not. So if they are the same, so basically if they are the same, we're going to set this Fij to be the diagonal one plus 1. Otherwise, we'll choose the larger one from the left and from the above. So we will get Fij equals this one. So with that said, then we are ready to return the result. So step 3. So we return the result. So basically we return the bottom right corner one. So now let's examine this for the special case. So this is for example 1. So we can actually print out the table. So if we compare the table here and the table here, so actually you can see one is the transpose of the other. The reason actually is that the final result does not depend on the order of text 1 and text 2. Right? So with that said, let's check for generic case. So yeah, this is a possible generic case. So there are quite a number of such problems, so which we can use the same idea, even the same format of code to solve. That's it for this problem. Thank you very much.